All right, this is section 4.7, rational equations and inequalities, but we're not going to see inequalities, only equations. All right, let's zoom in a little bit so we can get a closer view of this stuff. So we're going to solve rational equations, which means equations that have fractions. So to solve, find the domain and then multiply on both sides by the LCD. It means we need to find the domain and we also need to find the LCD. Okay, how should we approach this? Well, let's take a look at example 2 here. 1 over 2x plus 1 plus 1 over 2x minus 1 equals 2 over 4x squared minus 1. First thing you want to do is actually factor your denominators. So I cannot factor 2x plus 1 or 2x minus 1, but 4x squared minus 1 factors into 2x plus 1 times 2x minus 1. Okay, and now that I know that, I check to see my common denominator has to be made up of, include all the factors of all the denominators. So the factors involved in the denominators are 2x plus 1, 2x minus 1, and that's it, just 2x plus 1 and 2x minus 1. And so the 2 over 4x squared minus 1 actually already has those two factors. So I know what my LCD is, and I also know from there what my domain is. So my LCD is 2x plus 1 times 2x minus 1. Notice that's all the factors that there are throughout all the denominators. And the domain is whatever would make, exclude whatever would make either of these 0. So that would be plus or minus 1/2. So I'm going to say x cannot be plus or minus 1/2. That's my domain. And then my common denominator, it's already written there. I'm going to multiply on both sides times the common denominator. So on the right-hand side, I'm going to multiply times 2x plus 1 times 2x minus 1. And I could write it as 4x squared minus 1. It doesn't matter. On the left-hand side, times 2x plus 1 times 2x minus 1. All right, so on the left-hand side, don't forget you're going to distribute those two factors into the first fraction and to the second fraction. All right, so when I distribute to the first fraction, the 2x plus 1 cancels, and that leaves me the numerator 1 times 2x minus 1. I'm going to write that. When I distribute to the second, the 2x minus 1 cancels, so I have 1 times 2x plus 1. That's plus, don't forget, plus 1 times 2x plus 1 equals, and on the right hand side both factors cancel, so I just have the 2 on top. Okay, alright, I'm going to go ahead and distribute now. So I have 2x minus 1 plus 2x plus 1 equals 2. Minus 1 and plus 1 add up to 0, so I have 2x plus 2x, that's 4x equals 2. I divide by 4, right, because you're solving for x. Write that down just to make sure we know that's what we're doing. And I get x equals 1/2. Now, the reason why you want to know your domain is because you need to know what values of x are excluded from consideration for your answer. Here we got x equals 1/2. The domain says x cannot be plus or minus 1/2. And this is the only solution we have. So because that solution is not part of the domain, we don't have a solution. So we're going to say no solution. Okay. And your book might have something like the empty set. You guys remember that one? Okay. All right. Number 3, let's start it off. So A says solve f of x equals negative 10. Notice that's like the one we just did right now. So this is f of x is 2x minus 4 over 3 times x plus 1 equals negative 10. And because it's a rational equation, then we just go through and follow these steps that we just did on example 2. Yeah, so we're going to multiply times, find the domain and LCD and multiply times. Okay, so keep in mind right now the 10, the denominator is 1. Yeah, so really the LCD is just 3 times x plus 1. We've already identified it. And it also tells us what the domain is. X cannot be negative 1. I'm going to write that here somewhere. I'll write it up here. X cannot be negative 1. Okay? And then I'm going to multiply on both sides times 3 times x plus 1. And if I need to see it as a fraction, I can write that as a fraction is over 1. All right, times 3 times x plus 1. And again, if I need to see it as a fraction, just so I don't get confused, I can write it that way. Notice on the left-hand side, it's going to cancel out. On the right-hand side, you got negative 10 times 3. That's negative 30 times x plus 1. Yeah? And you're going to solve that equation. Let's solve it. So we got 2x minus 4 equals negative 30x minus 30. So I'm going to add 30x. And I'll have 32x minus 4 equals negative 30. I will add 4. Notice my target is that minus 4 to cancel that. So I have 32x equals negative 26. Divide by 32. And notice that gives me x equals negative 26 over 32. But if I reduce by 2, I get 13 over 16. Okay. So that does not contradict my domain, right? So if I did everything right, that should be my answer for A. Yeah? So your job is to find B, find the zeros. Yeah, and then C, find the domain. I think we already found the domain. So B, find the zeros. Yeah, that means find where f of x equals 0. So we can write that. 2x minus 4 over 3 times x plus 1 equals 0. It's your job to solve that equation. Okay? All right, we'll leave that for class. All right, let's go on to part 3, direct and inverse variation. So I think we've seen some of this. In particular, I think we've seen both direct and inverse. It says y varies directly as x if there exists a constant of proportionality k such that y equals kx. I think we've seen that one. But we're also including y varies directly as the nth power of x. And notice all that does is add an nth power to x. So you have the equation y equals kx to the nth. Right? That's the new thing here. Okay. Y varies inversely as x. If y varies inversely as x, then there exists a constant variation k such that y equals k over x. So that tells us when we see y varies inversely as x, then we write y equals k over x. And y varies inversely as the nth power of x, just add the nth power to x. Okay? All right. So let's look at an example. Suppose shoe size is directly proportional to height. So I'm going to call shoe size S and height H. Okay, so the first thing I can do is I can write the equation already, S equals K times H, because it's directly proportional. All right, if a person is 62 inches tall, notice that's a height. Where's the size 7.5? What would the shoe size for a person 70 inches tall? Round to the nearest half size. Okay, so I'm going to first plug in those two numbers in here. So the size is 7.5, be very careful, equals K times 62. Okay, and then we're going to divide by 62, and we get k equals, whatever we get for 7.5 over 62, let's work that on a calculator. And I get 0.120967, so I'm going to have to round that somewhere. Okay, I'm going to say it's about 0.121. Okay, that should allow us to get answers. All right, for a 70-inch person, so 70 inches tall. Notice this is a value of h. Okay, so I'm looking for s. So s equals k is 0.121 times 70 inches, and that should be, let's see, 0.121 70 inches times 8.47. Remember, we're rounding to the nearest half size, so that would round to 8.5. Okay. And we will leave example number 2, t varies inversely, right? Remember, inversely as the third power of w. And what happens to the power, right? Okay, so we'll do that one in class. All right, and this is it for section 4.7.